At WWDC 2026, Apple announced a new feature that opens up the Apple Foundation Models framework to cloud-hosted providers. And I am pleased to say that the Firebase team has built an integration that makes it possible to use Gemini models with this new API on day one. Hi, my name is Peter. I am a developer relations engineer on the Firebase team, and in this video, I'm going to show you how you can take advantage of this new API. What's truly exciting about this API, it allows you to use the same API calls no matter if you're using Apple's on-device foundation models or a cloud-hosted model like Gemini. This means you can pick exactly the right model for the job at hand. For example, on-device models are fantastic when you care about maximum privacy, zero cost, and offline support. They are perfect for smaller, specific tasks. But on-device models are smaller and may not be suitable for all tasks. If you need a larger context window or advanced capabilities or more reasoning power, you need the scale of a cloud-hosted model like Gemini. And thanks to this new integration with Apple's Foundation Model Framework, you can now use both in the same application using the exact same code. Consider this code snippet. It shows how you can use Apple's Foundation Model Framework to summarize text. This works great for short to medium-length texts, like most emails or short blog posts. But once you need to summarize longer texts like PDF files or an in-depth technical blog post, you might run into limitations. On-device models only have a limited context window size, and once your input exceeds this, the API will throw an exception. That is when you might want to start using a cloud-hosted model. Here is the same code for summarizing a slightly longer text using Gemini. That's right. All you have to do is add 2 lines of code to register the server model with the session, and that's it. But before going any further and demoing some cool use cases in a real app, I'll first show you how to set this up and explain why this is actually secure. To use Gemini via the Foundation Models framework, you need to integrate Firebase AI logic. Here's how. First, you need to add the Firebase SDK to your app and connect it to your Firebase project as usual. Firebase AI logic acts as a proxy. This means you won't have to add your Gemini API keys to your client app, where a malicious actor might steal it. Instead, your Gemini API key is kept safe and secure on Google's servers. As a second line of defense, you need to ensure that requests for the model can come only from your genuine application from an untampered device. For that, we've got Firebase AppCheck. It uses an attestation provider to ensure that all requests originate from a legitimate instance of your app. In addition, AppCheck supports one-time use tokens to protect against replay attacks. Once you've set up AppCheck, you can instantiate a server model using Firebase AI logic and pass it directly to Apple's language model session. Because Firebase AI logic integrates with Apple's language model protocol, you can now use Apple's Foundation Model Framework to call Gemini. If you've used the Foundation Model Framework in your app before, none of your existing SwiftUI views and data structures need to change. Let's look at how this helps in a real application. Here is Apple's Landmarks app. It is an app that uses Apple's Foundation Models framework for generating itineraries to landmarks all over the world. The original version of the app uses a static list of places for the activities on any given day of the itinerary. To make this more realistic, let's tap into some of the powerful capabilities of Gemini: grounding with maps and grounding with Google Search. First, I set up Firebase AI logic and instantiate a Gemini model. Now, I can pass this cloud-hosted model to Apple's Foundation Model framework. To ensure the model uses real, existing places when generating the itinerary, I use the Server Tools parameter to register the Google Maps tool. It's also a good idea to update the system instructions to indicate the model should use the Google Maps tool to ground its result. And now, the model populates the itinerary with real destinations and live coordinates. All I had to do was register the Google Maps tool. But sometimes, you need more than just location data. For example, your users might be interested in any special events taking place at a particular place, or they just want to know the opening times. For this, you can use grounding with Google Search. To set this up, register the Google Search tool when setting up the Gemini language model. This allows you to tell the model to generate all the details you'd want to show a user when they want to find out more about the place. In addition to the address of a place, these could be details like opening times or upcoming events. And the good thing is, you can even use the streaming version of the API. This way, you can update the UI as the model is generating output, reducing the wait time for the user. You can even use the add_generable macro to define the structure of the output you expect to make it easier to show the generated result on your UI. When using grounding with Google Search, keep in mind that you need to display Google Search results as well as the sources these details come from. And there is a similar requirement for using grounding with Google Maps. Our documentation has more details about this, including some code snippets that you can use in your own apps. Here is the code that you can use to extract the grounding metadata from the model's response. Finally, I want to show you one of the most engaging features you can build, visual landmark discovery. To demonstrate this, I've added Hamburg, where I live, as a destination in our app. Imagine a user is exploring the city and comes across this interesting building that looks like a ship. They want to learn more about it, so they take a picture. The app analyzes the image, identifies it as the Dockland building, and adds it to the user's itinerary. By the way, if you ever come to Hamburg, you've got to go on the rooftop of this building to enjoy the sunset. Best of all, it's open 24/7. Thanks to Gemini's multimodal capabilities, this can be implemented with just a couple of lines. First, you need to set up the Gemini model and pass it to the language model session. To identify the landmark in the image, you need to pass the image to the language model session along with a prompt that instructs the model to analyze it. The respond method uses a prompt builder that allows you to pass a multimodal prompt. Images need to be passed as CG images, so don't forget to convert the image before passing it as an attachment. You can use structured generation to ensure that the model returns its response in a format that can be directly mapped to a Swift type. With just a few lines of code, you were able to implement a pretty amazing feature, and you didn't have to implement a complex machine learning model yourself. And that's it! By bridging Apple's native foundation models framework API with the power of Gemini through Firebase, you get the best of both worlds. You can keep your app lightweight and private for simple tasks, and scale up to the cloud when you need heavy-duty reasoning. To learn more about how you can use this in your own apps, check out our documentation. The link is in the description below. If you have any feedback, please head over to the repository or reach out to us on social media. Thanks for watching, and I will see you in the next one.